This question we have the square root of some numerator over some denominator. And one thing you might check, one thing you might like look for is that okay, can we actually just simplify? Can I go 125 divided by 4 and actually just divide them? Because this would actually be the same thing as the square root of 125 a squared c10 over 4a 12c8. Like that would be the same thing, right? So then I could actually just like simplify those guys. But what I would recommend on this one though is I just kind of notice that everything in the denominator there is actually a perfect square, right? Because the square root of 4 is just 2. So the bottom here, like if you're just going to do the bottom first, this would be 2. And the square root of a to the 12, well, those are both even numbers, right? So what we can do there is we can say, okay, well, that would be the same thing as a to the 6. Because, if you're wondering about that one, the square root of a to the 12, well, how do we get that? Well, we want a to the 6 times a to the 6 because you can like add exponents, right? And if you see the pattern there, it's always going to be half, like with your exponents. So it'd be a to the 6 in that one. So if I look at my next one, c to the 8, well, that would be the same thing as c to the 4. All right, so then that is my bottom, and there's no more square root, right? Like I took the square root of all those things, so it's just that in the denominator now. And then up in the numerator, we've got 125 a squared c to the 10. And now I can work on just taking everything out, right? So what I want to do is I want to split everything up as some perfect square times something else. So let's rewrite this 125 as some perfect square times some other number. So I'm going to use 25 because I know the square root of 25. So that's going to be 25 times 5 is the same thing as 125, right? So I'm going to split it up like that. And then it's at this point that I could split up, like if this was a to the 3, right? I could split that up as some perfect square times some other number. But it's already a squared. So what I'm going to do is I'm going to rewrite this as a, or sorry, not rewrite it. I'm going to leave it as a squared because I know the square root of that. And the same thing with c to the 10. Okay. And that's all over 2a to the 6, c to the 4. All right, so now the whole point of that is I know the square root of 25, so it gets to come out as just 5. And I know the square root of a squared is a, so it gets to come out as just a. And c to the 10 comes out as c to the 5. So now I can rewrite this as, so 5, right? 25 comes out as a 5. A squared comes out as an a. C to the 10 comes out as c to the 5. And then I still have the square root of 5, right? That 5 is still trapped in there. And then this is all over 2, a to the 6, c to the 4. All right, so now we're almost done, but I just want to simplify what I can, right? I can simplify these guys up. So you can use exponent laws, right? Because I could say this is a to the 1, and then since we're dividing, you subtract. But the way I kind of like to think about it is just like, how many A's on top and how many A's on the bottom, right? So think about these A's. You've got one A on the top, and you've got 6 A's on the bottom. Pretend they're going to war. How much would the A's on the bottom win by? Well, they'd still have 5 left over, right, after they cancel those out. So up in the top here, we've got, well, here, I'll cancel that, and then this will turn into a to the 5, if that makes sense. And then with my C's, it's like I've got 5 C's up top, and they're going to battle with 4 C's on the bottom. So then those cancel, and we end up with just C to the 1 up top there still. So what we have left is 5 C root 5 all over 2, and then there was still a to the 5 left down in the denominator.